Hey, here we are, back again with a little bit of geometry. Chapter 5, Section 3, Proving Triangle Congruence by Side Angle Side. Alright, so if you have a triangle like this, and you know that this side as well as this side are the same in a second triangle. Oh. So I have another triangle with that same, and notice that the angle between them is the same. This angle is the same. There's only one way to connect those other two lines from here to here. If those two red lines are the same length as these two lines in the first triangle, then this triangle has to be congruent to that first triangle. So if two of the sides and the angle in between are congruent, then that third side and the rest of the angles have to also be congruent, because there's only one way to connect those two sides. So that's the side angle side congruence theorem. So if two sides, and here's an important term, the included angle. Okay, and notice how we write this side angle side, SAS. So the A is in the middle between the two. That's because the angle is in the middle between those two sides that we know. Okay, so the angle in the middle, or the included angle between the two sides that we know. If that's the same, if the two sides and the angle in between them, the included angle, are congruent to another triangle, then those two triangles are congruent. Alright, using this, we can write a proof here. Okay, we have, what are we given? We're given that BC is congruent to DA, and we know that BC is parallel to DA. So we know the length of this side. We know that these two lines are parallel. Now, we'll write down what we're given. Then we want to prove that this triangle ABC is congruent to CDA. And we could use the side angle side. Now, so that means we need an angle. So we have a side here, and we know that these two are parallel, so this can be considered a transversal between them. So we can take this angle and say alternate interior angles to that one. So angle CAD is congruent to angle ACB. This is our second thing, because alternate interior angles. And so here we have a side, here we have an angle. Now we have this side and this side. We need this side right here because it has to be the included angle. So we're going to have a look and see what we can say about this side. Do I know that it's the same for each one? Yes, because AC is congruent to CA, reflexive property. Okay, and that's my other side, and therefore I can say that triangle ABC is congruent to triangle CAD because side angle side. Example 2. In the diagram, QS and RP pass through the center M of the circle. What can you conclude about triangle MRS and MPQ? Alright, so we know that this is the center, so that means from the center to the outside, this has to be the radius in each of these. We can also say that this angle SMR, is congruent to this angle right here, PMQ, angle PMQ because vertical angles. So we know those are the same. We know that MS is congruent to MQ, and MR is congruent to MP because they are all the radius. In a circle, every point on the circle is the same distance away from the center. So they're the radius. So we can conclude that triangle MRS is congruent because we know that these are equal and these are equal. They are congruent to MPQ because side angle side. All right. You are making a canvas sign to hang on the triangular portion of the barn wall shown in the picture. You think you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS and PQ is congruent to PS. Use the side angle side congruence theorem to show that triangle PQR is congruent to triangle PSR. So we know that given that RP is perpendicular to QS, given, and we know, so we can conclude that angle RPS is congruent to angle RPQ because perpendicular lines, which makes it 90 degrees. And therefore, we know, and then we know that RP is congruent to RP, reflexive property. So we have this side, we have this angle and this angle. We need one more side. We need PQ is congruent to PS. That is given. So triangle PQR is congruent to triangle PSR. Side angle side. All right. And ladies and gentlemen, there you go. There you have it. Chapter 5, Section 3, Side Angle Side. Check in again next time for another fun lesson.